Hello, everyone, and welcome back to day 2 of Cybersecurity with Python and the Microbit. Today, we'll start with a little bit of Q&A if any questions came up as you were going through the homework or thinking about Monday. Then we'll actually backtrack a little bit, just make sure that everybody's feeling comfortable with especially lists, strings, and dictionaries. Then we'll go into radio basics. And then we'll do radio data, encryption, sniffing attacks and defenses, and brute force attacks and defenses. And some of this may end up bleeding into Friday, and that's okay, because even though the Friday's list is just as long, these topics are shorter, so we'll still have some time to like, if we're in the middle of brute force or even starting it, we should still have some time on Friday. Okay, so to kick things off, would anybody like to unmute and ask any questions? I'll also try to take a look at the chat.
Andy, I have a question.
Yes.
So if I have to teach cybersecurity, will this be like a year long or a semester, or how long can I use the Parallax Microbit or the Cyberbot? Is that Cyberbot? So
yeah, the Cyberbot.
would that be a year long? How would you consider that?
I consider it a 2 to 3 week enhancement to an existing cybersecurity class. This is not an entire cybersecurity curriculum. What it is it's kind of an enhancement or an addition to an existing cybersecurity curriculum where the students have the opportunity to experiment with IoT-like devices in a safe way that's easy to get started for both the teachers and the students. And if we add in the Cyberbot, also get some hands-on experience with the mechatronic aspects of cybersecurity and how a robotic device, for example, can be hacked. And it's all at a very fundamental level, and it's different from the cyber range type of activities that are done using where students, they log into a virtual machine that they can create a network of computers on and create a virus in one and infect another and set up a defense for that, clean the virus, that kind of stuff. So those types of cybersecurity classes, there is a curriculum that I'm not sure whether it goes for a semester or a year. I'll have to ask cyber.org about that. But I was planning on talking on Friday about a more full-fledged technical cybersecurity curriculum where they actually prepare the students for CompTIA Security Plus certificates. And I just sat in on a seminar about that. It's very interesting what they're doing. And so I was going to show you some of that on Friday. That's a much longer curriculum than this. The Cyberbot curriculum, that lasts somewhat longer because there's a fair bit of robotics and electronics. And so it can end up filling a semester, or it can be part of a semester, depending on what the teacher selects from what we offer to teach. And we do have a course coming up with the Cyberbot, and I'll be announcing that or mentioning that it's available for signups also on Friday. Excellent question. Are there any others?
Yeah, Andy?
Yes, Mark.
I think this would tie into my computer science A. What is it?
I think that there are quite a few scripting / programming standards addressed here. In a way, it seems like actually a better fit for computer science. I really like the, computer science, it covers quite a bit. Whereas if you're looking strictly at cybersecurity standards, it's a much smaller slice of that pie.
This is the one that's for college credit.
Okay. Yeah, I mean, that is another thing that I was planning to talk about on Friday. We have standards alignments posted in the teacher resources. And so I was going to go over the teacher resources on Friday too.
We have Rosa's hand is up. Mark, that was your question? Because I see your hand is up and Rosa's hand's up still.
Hello, Rosa.
Hi, Andy. So in line with the first question, you said it was 2 to 3 weeks. So how many hours roughly?
Oh yeah, so on a 2 to 3 week, I'm thinking of 7 hours or I'm sorry, 5 hours in a week. So actually, I think I guesstimated it at like 14 to 28 hours, depending on how much time was spent on each topic, how in depth, because there's different levels of depth that you can ask the students to dig into. But my thinking is that essentially 3 weeks of class time could be spent on something like this, 2 to 3 weeks. So if you make it 2 weeks, it would be a lighter treatment. And certainly I'm sure that a number of cybersecurity classes, there's not a lot of room anyway. And so this might be a welcome add-on, say near the end of the class. Okay, so for homework, the top priority homework was to have a pair of microbits with the terminal chat through microbits.py script loaded and running. So if you don't have it loaded and running, I can go ahead and paste to the page, but I'll show you first. Actually, I'll start by going to the page.
Got my screen up.
Okay, so bidirectional texts. Okay, so this is the page with the script. So I'll go ahead and first paste in the page to you. Paste. Okay, so when you go to the page I just pasted in, just shade and copy the entire script. I almost missed a line there. And then you want to have both microbits connected to your computer. And I'll go ahead and nuke my previous work here, just so you can see what it looks like to get this going. And I have unfortunately a third editor. Better get that cleared also. Okay, so now I'm starting from scratch, and I'll take this page right here and paste the script in, and we'll leave this one as microbit transceiver A. And then we'll go over to the second editor and paste the script in. And we'll change that one to transceiver B. Then we want to connect. And when you have, some of you may have more than one computer, so you'll just be getting the chat, and you'll have one microbit connected to one computer, another microbit connected to the other computer, and then you'll just be pasting. You'll be on Zoom with both computers, and you'll be pasting in the link and then getting the script and pasting it in. So I'm connected 2 microbits, 1 computer. So that's why I have 2 python.microbit.org editors open. Then the tricky part, if you have 2 microbits connected to 1 computer, or in my case, 3 microbits connected to 1 computer, is that you have to pick the right microbit. And I usually kind of look right at the tail end here and make a note of the numbers. And so since this is microbit A and this microbit serial number is ending in A, I'll go ahead and select that one. And then I'll select another one for microbit B. And I'd make a note that serial number ended, last one display, it ends in 3. So connect to that one, great. Now we can flash the scripts into both microbits. And then go to the Open Serial button. And for some reason, I have to click it twice in order to get just one copy of the introductory screen stuff. Okay, so now we're ready to text each other. So, hello, exclamation mark. Now, when I hit enter, we'll see hello appear over here. Boom. And what's happening in that case, and then I can come over here to the other microbit. And normally this is going to be students in a classroom, so they'll each have a microbit connected to their computer, and they can actually go and pick different channels so that they can basically pair off and each pick a different channel. I think the channels go up to 83, and it starts at a default of 7 and then goes up to 83. And so they can pair off on channels and all test out this chat program. And so, script. And so here is the script. And so let's make sure that everybody can get that running. And then we will basically come back to that later in the this session, but I want to make sure that everybody can do that their computers will do it. This is kind of what I've viewed as the big potential weakness in this online cybersecurity class, is if we have a large number of attendees whose computers for whatever reason won't cooperate. So I'd like to see how many of you can get that going.
Andy, I got it to work in the homework. Do you still need me to do it now?
Could you say that one more time, Rosa?
I got it to work during my homework time. Do you still want us to run it?
Oh, absolutely, yes, yeah.
Run it again? Okay.
Yeah.
One other question. So when the students are in the classroom, let's say 2 of them want to chat with each other, they have to, pardon my ignorance, they would have to choose the same channel, correct?
That is correct. And there's actually much more to that. And that's where the cybersecurity tie-in comes in, because I think you can imagine in a classroom what's going to happen is that, some of the more, shall we say, energetic kids in the class are likely to decide to try out different channels and see what their friends are saying to each other, and maybe even insert a message, some kind of silly message into some other pair of students' chat. And so
Corey is mentioning something along those lines here. This is my students' favorite part, especially when I enter the lesson by taking over all the microbits and showing a heart.
That's awesome.
There's a question there though. How many channels are available?
I believe it's 83 minus 7, but I could be mistaken about that. Let me, so let's see, 83, so 466, 76. Let's see here. I have a note to myself about that, and I hope it's right here. No, it's probably in Radio Basics. Oh, this is Radio Basics. Okay, so this is the developers of the microbit runtime, and this is some lower level discussion on the radio. And
oh, it's 0 to 83. A link from James.
Okay.
from the MicroPython. That there's 84 channels numbered 0 to 83.
Okay. For some reason, I guess it must default to 7. For some reason, I was thinking that anything below 7 was not doable, but that may not be the case.
Sorry to distract.
Yeah, no, that's really good information. So channels 0 to 83 work. That's really good because then, you know, that's pretty accommodating. Basically a class of 20 could all be 2 channels apart. That would be 40. Yeah, so you could actually stay 4 channels apart in a class of 20, or say 3 channels apart if it's a little over 20. I don't like to do channels right next to each other because I do think there's some possibility of interference. That's funny. I thought it said that here. So sorry about that. And thanks to whoever did the save text on that one. Thank you, James.
And the quick question.
Yes.
These 2 computers that I have connected right now, they're in the same internet environment. What happens if I have another student with another connection? Is possible to continue do this program or no?
Oh, yeah. Yes, absolutely. The students can be on different computers, different internet connections, because it is not going through the internet. It is actually going from one microbit's radio to another. And that's one of the reasons that we liked the idea of cybersecurity with the microbit, is simply because a radio network allows you to not have to worry about trying to manage a special network in your classroom that's separate from the school's network in order to make it safe to put an IoT device on. So although it makes it maybe less internet-y, it still allows some of these lessons to be conveyed. All right.
Thank you, Andy.
Certainly.
Hey,
Okay, so go ahead.
I had something funny happen to me when I was doing the homework. Like at times the first message wouldn't make it. But then I thought, well, maybe it's more than 29 characters or something, the meaning. But I tried the ones in the examples, but then the subsequent ones that I entered, they worked. So
okay, so sometimes what happens is it has to do with, I'm looking for the slide. It has to do with your power settings. So like if you have a laptop with a little battery icon in the lower right, one of the things you can do to help make sure that the Chrome browser doesn't miss any of those messages or parts of them is to wind up its performance all the way. So in here, I was on my taskbar at the bottom of a Windows machine, and I clicked the little battery, and then it presented me with this slider that allowed me, and it was sitting at best battery life, and it allowed me to wind it all the way up to best performance. And when I did that, I started missing fewer messages. And actually, I haven't seen any messages dropped for a while, so I'm interested. Maybe, Rosa, we could experiment a little bit with that after the course, if you have some, after the workshop's over, if you have some time. Okay, so hopefully I'd like you all to work on that as I talk about a few things. If you don't have your microbits chatting with each other, try to get that going, and then also, you know, give me a shout if you're stuck at any point, and that way we can get you unstuck before we start actually doing that, because there's some material to cover before then. Okay, so first up, close everything to the right here. First up is just a recap of dictionaries. So in Python, a dictionary is a collection of what are called key value pairs. So there's a key, and that's the name of the value. So here's one key, score. Its accompanying value in its key value pair is 1,000. Here's another key, name, and its accompanying value is the string Sir Lancelot. All of that is always enclosed in curly braces. And as with tuples and lists, you go ahead and just say, give it a name, like you would, 1.414 or the number 2, the number 3, etc. So then you will have a dictionary. Dictionaries are very important from the standpoint that these key value pairs are what are used to do most of the heavy lifting of information between browsers and servers on the internet. Because being able to send and receive key value pairs, they're usually called JSON strings for those of you who are teaching JavaScript, or JSON strings/files. The JSON data is arranged in key value pairs so that basically if a browser receives a JSON string/dictionary, it can say, oh, let's check name. Gee, name is Sir Lancelot. Okay, let's check Sir Lancelot's score. Oh, he's got 1,000. And it's much easier than, say, using a list where you have to say, oh, the 5th element in the list must be Sir Lancelot's score. That gets really difficult to manage. And so, so that's why we use key value pairs for communication. And that's going to be important today in just a little bit. Now, if you have a dictionary like this, you can say, well, gee, if you gave it the name info, you can say info and then put score in between square brackets, and it'll return you, in this case, the number 1,000. You can also say info of score equals and give it a new value. And that updates the dictionary definition. So that is dictionaries. And this is not a very exciting program, but it shows basically in action, creating a dictionary, checking its element, changing its element, rechecking its element, and displaying its element. So so that's and basically there's an entire chapter that talks about dictionaries. It's fairly short, and the students go through and they try exercises to just become more familiar with and comfortable with using dictionaries. And again, it's important because not only is it how information is transferred between, say, web browsers and servers, it is also the best way to exchange data between microbits when you're thinking of more than just text, when you're trying to keep an application going. And we'll have an example of that shortly. Okay, next up is exceptions. Now, exceptions are usually basically, you can take some code that worked. That might be this. So you got some code that worked in one way, but what happens when you throw something unexpected at that code? Well, it might break, and then the microbit will stop executing code altogether, and it'll throw an exception, and it'll tell you what the error code was. And so here is an example, and this one is worth trying. I'll go ahead and paste this one into you. Copy. Chat. There's my chat. Okay, so what I'd like you to do is run this one in one of your browsers, and then you'll need to you'll need to paste in your radio communication later again. So we'll go ahead and paste it into one of the browsers and run it as is and see that it works. So here we are. Basically, we divided 20 by 5 and got a result of 4. So that worked. Good. Now, let's try dividing 20 by 0 and see what happens. So we'll go ahead and flash it. And then, wow, we don't have an answer for that. It says 0 division error, divide by 0. But also what's probably happening is that the microbit is going to be displaying a message talking about the divide by 0 error. And the problem is, if you had an application running where you're communicating from one microbit to the other, maybe controlling a robot, maybe exchanging some other data, the microbit just stopped completely. The application is done until you restart it. So that can be problematic. And again, in the world of the internet, you've probably experienced that when you had a web browser freeze. Almost universally, the reason behind web browser freezes is that exception handling was not done for every case. And you threw a curveball at the web browser, unknowingly, of course, and it froze on you and you had to refresh it and you may have had to refill out the form. That happens less and less as web developers get more sophisticated, but I have still seen it happen. It's happened to me a couple times this year still. So that is, so now we saw in this activity how to break the code. Now, it's true that you can simply anticipate that and add an if condition that prevents the user from typing in 0, but maybe the user might type in the name Fred accidentally or go. That'll freeze it up, but for a different reason. So if the user gave you 0 for denominator, won't deal with that text string necessarily.
We have a hand up.
Yes.
Tamika's hand is up.
Yes. Hi, Andy. So I was conversing with my 2 microbits and my browser is frozen, as you just mentioned, but I'm able to erase any of them. I'm not able to erase, to paste anything else. I don't know if I'm frozen or if I need to disconnect something.
Well, the first thing I'd try to do is hit the refresh button.
Okay.
And then if that doesn't give you a new, if it doesn't start responding to your mouse and cursor and keys, you could also close the Chrome browser and reopen it.
I actually figured out. I didn't close my serial. That's what it is.
Oh, well, thank you. Let me think about this. So you didn't close your serial. Oh, I see. So you were clicking the serial and trying to put the code in.
Yes.
Got it. Okay, that was easy. Nice solution though. Good. You caught it. Very good. All right. So here is that same program, except for what we're doing is we're inserting the part that might have an error, that might suffer from some kind of bad value inside the try code. Now, if there's an exception, this part of the script displays it. If there's not an exception, this part of the script just kind of takes the ball and runs with it. It's whatever else kind of completes the operation. And then this part of the script we want to do regardless of whether or not there is or is not an exception. That's a very quick explanation. And it's, I'm not overly, I'm not worried about understanding exception handling inside and out. Just kind of, if we can give you an initial 50,000 foot view of it, that's all that's needed. And so what I'd like to do is paste in this code, if it's not too long. Paste, enter. All right, so go ahead and try that one. I'm going to try these in 2 different microbits to compare and contrast the response.
And what does the type see when you define ET as type E? What does that do?
Just a second, and I'll try to answer that. I forgot to tell you all that when you paste this second piece of code in, if you run it as is, it'll work because the denominator is 5. So the try catch finally, or I'm sorry, try except else finally will work the same way it did when we did the other one. But when you go and change 5 to 0 and run it, what it'll do is it'll say that there was an exception, and to try again, but it's not displaying any error. The microbit has not frozen. And that's the important part, especially if you're using this in robotics, when you're doing radio communication stuff. If you send it the wrong value, the robot will freeze and you'll actually have to get up and go and restart the program if you don't have exception handling for some of your applications. So that's what I want to emphasize here, is that this allows the microbit to kind of cast aside the exception, say, there was an exception, but I'm going to keep going. And so that is exception handling. Then I wanted to talk a little, and then at the very end of exception handling, what we have, the students will have gone through and learned about how to respond to specific exceptions. And so when you divide by 5, nothing bad happens. When you divide by 0, it responds to the 0 exception error by saying can't divide by 0. And then when we set the denominator to hello, it recognizes that also and says, hey, we expected a number, try again. And it's also in an infinite loop, so you can actually type in your numerator and denominator. It's in an infinite loop, and it's using input like we did with the countdown during, we typed in a number that the microbit should count down to, and then we typed in a message. So this is a similar thing where we're typing in 2 numbers and doing the division problem repeatedly. And then strings. So we had some homework about that. First thing is strings can be contained by quotes, double quotes. If you want to have a string that covers more than one line, you can use 3 single quotes to begin and end it, or 3 double quotes to begin and end it. This is also the way that we typically comment out a section of code. So for example, if, I didn't mean to do that, I'll do it over here. Oh, well, okay. So if example, I wanted to not do the else section of this try except finally, I can just put 3 quotes at the beginning and the end. And that actually changes this from code to a string of text. And as a string of text, the microbit just sees, oh, gee, there's a string of text. And so this effectively is the way to comment out a block of code, as opposed to commenting out a line where you would use a hashtag.
So it's triple single quotes. Could it be triple double quotes?
It can be
Common
triple
sense.
single quotes or triple double quotes. The effect is the same. Okay, let's see here. Okay, next up, I didn't want to say much about strings for exchanging data. Basically, this page kind of emphasizes to students, well, here is a string. I'm declaring S1 to be a string, and I'm declaring N1 to be a number. And the idea is that you can have numbers, which are integer values, and you can have strings, which are string objects, and they're not interchangeable. However, there is a very important way to take a string that contains digits and change it to its corresponding number and vice versa. And so this is one of the pages we had you read in the homework where it started out by saying, oh, look, here's a string, and each character in the string has an index. So there's 12 characters here that goes from 0 to 11. And you can access individual characters by saying, you know, for example, S is the name of the string. So S of 6, or, you know, S with a 6 in square brackets will give you back the 6th character, which is an S, and that'll end up being stored in C. Now, there are functions that you can do with strings. One is ORD. That gives you the ASCII code. Let's see, where is the ASCII? I believe the ASCII chart is on the first page. Yeah, so here is the ASCII table. It was on the first page of the chapter. And so 65 is the decimal code, or hexadecimal 41. That corresponds to the letter A. 66 is B. And then we've got the whole list here. I'll just go ahead and paste that in the chat in case you want to refer back to that at any point. Okay. And so ORD gives you that ASCII value. If you say ORD of capital A, it'll give you the number 65. If you say CHR of 65, it'll give you capital A. So that's the inverse of ORD. If you want to know how many characters are in a string, you can ask for its length. So you could say len of S, and it would tell you actually 12. There are 12 characters from 0 to 11. And then if you have a number like 1, 2, 3, you can say, put that in str of, and then it'll give you 1, 2, 3 in quotes when it's done. And so then for an optional challenge, we had you take a look at, okay, you know, what's going to happen here? S equals 1, 2, 3, N equals int of S. We added 1 to N. So 1, 2, 3 in quotes is a string, but this gives us back the corresponding number. And then we can add 1 to that number and we get 1, 2, 4. And then there's quite a few other things that are built into strings. Strings are an object. So you can say string.find and something that you think might be in the string, like sequence. And so string.find would give you the index number of that S in sequence. And there's a whole bunch of them, but I don't want to belabor this too much. I hit the important points for what we're going to be using in the cybersecurity coming up. So that is strings. Then the homework, does anybody want the solution to this? So this was basically the question that I put out was, you can optionally display the results of these two code snippets. And the answer to that optional in the homework is here. Let's see here. So I'll give this to you and you can try it at your leisure. Chat. Paste.
Are you putting this information somewhere else as well? Because once we get out of the chat, it's gone.
Okay, so yes. So here we are in the homework thing, right?
Mm-hmm.
Okay, and then here is the homework solution, and this is as a screen capture.
Okay.
And then if you drag the little bottom separator upward, the actual code that you could copy and paste into your editor is right there.
Does that
Okay.
have the right indentations?
Yes,
Okay, good.
Thank you.
you're welcome. You can also hit me up. We do have the chat log, and so I can go sometimes and grab if there's a particular thing that I made a mistake and did not, include a copy of it accessible to you. Like I sent a zip of everything from Monday. If there's something I missed, yeah, just go ahead and let me know, because I can look in the chat log and grab it and give you a copy.
Thank you again.
Certainly. Okay, so next up is radio basics. So this is where this is where that chat first happens, and where students either hack each other or get hacked by their teacher. And so here is the back of a microbit 1.0. The positioning of the radio antenna is a little different, but this is the antenna right here. And this is the chip, the Nordic chip that has a low energy Bluetooth transceiver. But they don't just do, it doesn't just do Bluetooth. It also does their own proprietary Gazelle protocol. And that is what we're using for this. So the chat that you've seen so far was using the Gazelle protocol. And there are some lessons about, what is the frequency of that the radio transmits at, and here's the 0 to 83. I wrote that, but then completely forgot it. Sorry, folks. And thanks again, James, for giving me the correct info. And so we talk a little bit in general about radio, and then we do some more rudimentary stuff. So this page just has a script this activity has a script that has one microbit send, and then the other microbit display the results. So this is a script that is just sending testing 1, 2, 3. And then there's a receiver script on the next page that receives and displays those testing 1, 2, 3s. And then we talk about, hey, what happens if you change frequencies? Can you still see the messages? What happens if you change frequencies on only one versus both? With one, they won't be able to see the messages. If they change the frequency on both, the messages will go through again. And then there's also an introduction, very rudimentary, to frequency hopping, which is changing frequencies periodically, and that is part of how Wi-Fi is made secure. It's also things that pilots do when they switch channels in agreement with the tower or another plane. Then this is the bidirectional texts. And so now we'll go ahead and make sure that we've all got that working. Was everybody able to do this already? I'm seeing one nod. More nods, good. Let's get some thumbs up. Oh, you guys are awesome. Okay, so we've had one computer freeze out of the whole group, or rather one browser freeze out of the whole group. That's pretty good. And I am sorry to the one browser freeze. If you're willing and able to hang out for a little while after, we'll try to take a look at your computer settings. Okay, so we've already done this, and I think just for the sake of anybody who's watching the YouTube video, I want to make sure. Okay, so here we go. Bidirectional texts. And again, it was this script. And so I'm copying and pasting the link to the page again. And you might want to save the script and have it ready to go later also. And then I'll run it just to demo it. Copy. Close serial. Paste over. Oops. Change this one to B. Flash. I usually wait for one to finish flashing before flashing the other. I really don't know if anything bad can happen if you don't, but I'm trying to go conservatively since I don't want my browsers to freeze during the workshop. Okay, so I can type in hello, and it appears over here. I can type in hi. I want to hit enter, it appears over there. So that's all working, very good. And this will be one of the applications that we use in a little while to do encryption so that somebody who's watching can't necessarily see what exactly you're saying. Radio data. Oh, any questions? Okay.
Yes, I
Wait.
do have one.
Yes, Rosa.
And that's back to the ASCII. Is that the same mapping as the, I mean, I know it's for the microbit, but is it for all computers?
Yes.
Or pretty much, okay. Thanks.
Yes. The A in ASCII is for American. I don't want to mess it up, so I'm just looking at, yeah. So the American Standard Code for Information Exchange. So this is a very widely used code. Essentially, every time you hit a key on your keyboard, well, there are codes that are now taking into account different language characters. So I can't say for sure that it's still sending ASCII, but it used to. So, but ASCII is still very common and widely used. So this is the ASCII that you will see in just about any other microcontroller as well.
Andy, I got a question.
Yes.
I put my receiver A in, and I got a line 5 error, syntax error, invalid syntax. I have from microbit import star.
Okay, so it's line 5 that it's saying it doesn't like.
Yeah, yep. Line 5 syntax error, invalid syntax.
Is it indented? Like so?
No. Needs to be
Okay.
indented.
No, it doesn't.
Okay.
We do not want it indented. Now did this happen to both radio transceivers or just
No,
one?
I'm just working with one right now.
Okay. I'll copy and paste all the code into your, if you want to save that as like, terminal broken or something,
Yeah.
you can save that and we can look at that later, and I'll copy and paste in the code. It may have been something like maybe the indentation from the didn't carry through from the web browser to your editor. From
No,
the
I
web.
actually took it off the page.
Okay.
From up
Yeah. Well, so try it. Try the one I pasted into the.
Okay, that's going to be a problem because I've got one computer that's doing the video from you guys. I got the other one that I'm doing my primary microbit stuff in.
Okay.
So let me put it in this one.
Now, so Stephanie, can you possibly recap how to reduce the size of the Zoom presentation so that you can switch between Zoom and the editor?
Yes, if you are hovering over the window where you see the presentation up and move your mouse towards the top center of the screen, you should have a little bar drop down that says View Options. If you click the View Options, you'll get a drop down menu, and then you can choose Exit Full Screen. This will allow you to resize that window and open other windows next to it.
So radio data is the next chapter that I'd like to talk about. And hopefully, let me see if I can zoom in on this a little bit. There we go. So in radio data, do you remember this application that we did previously where we had we entered the number of seconds to count down and then the message to display after countdown? Does everybody remember that? Can I get some nods? Okay, great. So what we're doing here is we're splitting the job that one microbit did into one microbit transmitting it and the other displaying it. So one microbit is going to talk with you over USB. That microbit is going to send over radio to the other microbit. That other microbit is going to actually parse a dictionary that has the number of seconds. See that seconds :3. And then after is the message to display after, which is liftoff, which is what we typed in here and here. So I'm sorry?
I got it.
Oh, excellent. Excellent,
Yeah.
Mark.
Yeah, it said from terminal chat through. So there was a from there, and I got rid of that because it's before the pound sign.
Okay.
Yeah, it's almost set.
So there was basically some extraneous maybe code from a previous program or something?
Yeah, it could have been, or it could have been because I copied it from the wrong spot. So.
Oh yeah, yeah. Like if your target with your cursor doesn't quite make it to the end or makes it beyond make it to the beginning or goes beyond the beginning type of thing.
Yeah, yeah.
Yeah. Okay. Yeah, I had a feeling something like that, but I couldn't predict what. All right. So so let's do this one because this one's pretty cool, and then we'll take a break. So this is data packets, and we'll do send and receive packets. So there's basically a sender script and a receiver script. So I'll paste you the link in a second. I'll show you how to do it first. So here's the sender script. We'll copy that and then paste it. Now, I really want to emphasize, and I'll probably say this again, maybe on Friday at the beginning, that this is not the way to learn it. This is the way to fit everything into a 6-hour workshop, but it's not the way we want students going through it. Ideally, the student will actually set the editor, side by side with the, okay, where did that go? Okay, so let's see. I don't want to minimize this time. I just want to take it out of full screen. I think I just put it into full screen. Sorry about this, folks. I'm not really very good with the Mac. I'm more of a Windows user, but the Mac is better for not crashing when I present.
And it's more expensive.
Yeah, considerably. Okay. Let's see here. So I think I'm just going to have to go back to okay. So if we open radio data, the main idea here is going to be for students to have their editor next to their tutorial page and to actually manually type in the program, because that is what will make it possible for them to understand that and experimenting with the code will make it possible for them to understand it well enough to retain. If you just look at something, copy and paste it, learning, isn't necessarily happening. Yeah, you're getting maybe a summary view of it, which that's appropriate for this course, but in the classroom, we definitely want the students, typing in import radio dot on, and for yourself too. Really the best way to do it is to type in these code examples and go through it one project after another. If the goal is to be able to understand Python well enough to teach it, that's going to be an important step. So we're sticking with the summary right now, but consider going back and going through and hand entering your examples. All right, so with that said, I'll go back to my bad habit of copying and pasting here. So I'll copy and paste in the transmitter and the receiver. And then I'll flash the transmitter, no, I won't do it. I'll flash the receiver and take them both into their open serial button. Okay, then enter countdown to start. We'll just do 4 seconds. And then shout hooray. So when I hit enter, I want to see that happening over in my receiver microbit app. Okay, 43210, hooray. So that worked, and notice that it received a dictionary, and then it used those techniques I talked about earlier to find the after field and to get the value that corresponds with it, which is hooray, and to find the start field and to get the value that corresponds to that, which is 4. And then it uses that 4 by, yeah, so here it is, value dictionary of start, value message equals dictionaries of after. And then it uses value to say, while value is greater than equal to 0, print the countdown. And then after you're done printing the countdown, print the message. So there is an example of a radio application. And that is another example that we will look at how to protect from hacking after the break. And so it is 4:06. So let's have all of you come back at 4:11. Sound good?
Yep.
So
Okay.
Andy, do you want us to copy that and run it? on our computers now, or-
Rosa, yes, I'm sorry. Yeah, what I meant to do was I
okay.
meant to give you the link to that page in the chat so that you could try it out. And so we'll
Yeah.
give you some time to try it out after the break.
Okay, thank you.
Okay, so there it is in the chat. That's a
Thanks
very
a lot.
worthwhile one to try out, I think. And then I'll stick around for any questions, comments, random ideas, anything like that.
And the one quick thought is we do pair programming. So would you suggest, for example, we line up the students in a table and one pair is the sender, another is the receiver, so they're next to each other and they sort of see?
Yeah, although
Is that a good idea?
having them next to each other won't necessarily be required for the radio stuff. They can
Okay,
go to
yeah.
across the room.
Right, but they can see the message, right? Correct?
Yeah.
Just for the sake of seeing. Or should we have them do exactly what we're doing that we can see? both?
Well, I mean, so we're going to have a pair of students and a pair of microbits. I wouldn't want to do I mean, you could do a pair of students with one microbit and a pair of students with another microbit, but that usually, I would avoid that, especially with the low price of the microbit. One-on-one for this, I think, would be important so that each student got to have the experience and got to participate. If you're comfortable with, managing the students so that they switch off every so often, and the one that had their hands on the keyboard is now backseat driving and vice versa, then that works. And I can tell you from experience that during in-person workshops, when teachers paired up to work on a robot, there was some really nice collaboration going on. But when the microbit comes into play, when it's just the microbit and you're doing these applications, first of all, like I said, the microbit is so inexpensive that I'd recommend getting one for each student as opposed to pairing up students. I like to pair up or even make groups of students when after they've built their skills a little bit. Sometimes a group project is really good. A lot of industry representatives are looking for students that have had experience working in groups. I've also seen universities take that too far, where every lab is a group lab. And so the experience that some students have had working in groups is how to do absolutely nothing while the other folks in the group do all the work. and that's their strong group worker experience that they've gained. So yeah, I try to vary it.
One other question, why in one of the programs you said it says copyright, and something with MIT license.
Oh, yeah.
Why is that?
So that I think was because I put it up on GitHub. I think I know which one you're talking about. Let me get this. Let's get this Python editor back on the right desktop. Okay, now I'm going to look for terminal chat, I think is one of them. Yeah, so the MIT license basically gives you permission to use it, but absolves Parallax of responsibility if anybody gets hurt. You know, basically the user has to take all their responsibility. So if I did site:parallax.com MIT license. So this is in the Parallax reference. So so that this is the text of the MIT license. And basically what we're saying, what it says, it's designed to make sharing safe for individuals and companies so they can share their intellectual property. And so they say, yeah, you know, go ahead and use it. But the conditions of using it is, first of all, if you hurt yourself or somebody else, that's on you. And then secondly, you know, if you have any, if you damage your data or anything else, that's also on you. You know, you're allowed to have this, we're sharing it with you, but you have to take full responsibility for using it. You can't come back and say, oh, I just erased my, you know, whatever, and it's Parallax's fault, so I want Parallax to pay me. That is the intent of the MIT license.
It sounds like the
Thank
open
you.
source license. Or
Yeah, there's a GNU open source license that's similar.
yeah,
The wording's a little different, and you know, I don't know the. Let's see if I can look that one up.
because I know that the open source license, you can change it and make it your own, but they probably don't like that at MIT. So
Well, yes, the MIT license is very open. It doesn't really even talk about, I think if I remember correctly, GNU, you basically have to cite where you got your software from.
Mhm.
But MIT is just use it, but you take full responsibility for using it. So I believe that GNU does add a little thing about recognizing where it came from, but I'm not 100% on that. So, but this is another, the GNU general public license is another one that's commonly used. Yeah, good point, Mark.
thank you.
Okay, is it 11 past? Oh, it's 13 past. Is everybody back? Hey, welcome back, everyone. Okay, so now the dive into cybersecurity. Oh, actually, I'm supposed to give you some time to do the data exchange. So again, this is just something where you want to make one microbit run the sender script, the other microbit run the receiver script, and then test it out and make sure that you can count down by setting the countdown time and the countdown message in one serial terminal. And when you hit enter after your message, if you have the other terminal running, do that again, 5. So then you can see it happening in the other terminal.
Cool.
One interesting thing is that there are some applications where the dictionary actually is reconstructed in a different order from where it's transmitted. And that's actually okay, because since you're actually asking for the value that's associated with a particular key, the scrambling only happens at this, like after liftoff might be to the right and start 5 might be to the left. And so it can still find after and determine that the value is liftoff, or it'll still find start and determine that the value is 5. Okay, how many people have gotten this to run? 1 thumb up, 2, 3, 4. Oh, you guys are doing great. Okay. Good job, everyone. I'll go ahead and move on, unless I hear somebody give me a shout out to slow down. Okay, so let's first talk about encryption. Now that we've got the scripting basics down, one of the most rudimentary forms of encryption that you can do if you're using, there are other ways to encrypt the microbit data, but I wanted to start with leaving the actual channels wide open and just learn a little bit about encryption. So here's an example where we start with the plain text, that's the unencrypted text of hello in capital letters. And after applying the Caesar cipher, where we go ahead and shift a certain number of characters down the alphabet, we get our ciphertext. So if you take your H, that would, and if you call your encryption key 5, you can jump over 5 letters, and anytime you use H, you actually use M. And anytime you use E, you go over 5 and you actually use J. And so hello comes out MJQQT, and that's a very basic encryption. And if you want to decrypt, then you have this MJ QQT, and you can say, well, gee, the key is 5. And so in order to get from the ciphertext back to the plain text, you'll go ahead and move back 5 characters to get to your H. And so the students, and then of course, if you're near the end and you're going to a certain number of characters to the right, you want to wrap around. So when you go from Z to A, that counts as 1. And then, so X would actually be C if your key is 5. So this is an example of the Caesar cipher. And there's quite a few examples using it. First of all, we can encrypt a single letter using a fairly simple script. And it's pretty clever. I didn't do it this way. Tommy Gober at cyber.org did it this way, I believe. Oh, wait a minute.
Andy,
Yeah.
do you know who invented encryption?
No, who invented encryption? I mean,
Hedy Lamarr, the actress. No, seriously, she invented this.
Okay.
Frequency hopper.
Amazing. It's amazing that this actress
The
invented.
frequency. Yeah, she
Yeah.
was a radio expert as well as an actress.
Right.
I know who you're talking about now. And
Yeah.
thank you, Sarah. Well,
Then just a quick fact. I don't know.
Well, I don't know that that's inventing encryption, though. I mean, the fact that it's called the Caesar Cipher, I think, is kind of pointing to a slightly older character in history that
Yeah.
you,
He did use it.
yes,
It was spread spectrum that Hedy Lamarr invented,
yes, yes,
which is frequency hopping.
yes.
Yep, yep. It's pretty amazing.
It is, I agree. Yeah, I don't know where historically the very first instance of encryption was used, but the Caesar cipher is kind of a popular starting example. And, you know, I am given to understand that Caesar did use it while, you know, making his conquests for military communication. Anyway, so what we do is we start with a string called alpha. And this is something that was learned in strings, that you can say string name dot find and a letter, and it'll give you back the index. Then what you can do is you can say, well, if I know the index, I can add my key value. We've been using the number 5 to that index, and then go and find the 17th character in my alpha string. That's R. So let's see here, starting out. So starting out, we know that M is the 12th character right there. And that's because we did alpha dot find earlier. I believe that that is on the previous page. Sorry, no, it's not. Oh, yes, it is. Okay, let's try this again. So basically, alpha dot find M, that's the 12th character. And then to encrypt it, we say, oh, well, index is 12, that's the letter M. And we'll add our 5, that's our key. And then we'll go and find the 17th character, which is R. And alpha of 17 will give you back R, and that'll be in result. For the circular shift part, there is a thing called the Modulus Operator. And what the Modulus Operator allows you to do is say, well, gee, what's the remainder of the division, in this case of 26? So 24 modulus 26 is 0. 26 goes into 24 0 times, but the remainder is 24. So in other words, 24 is unchanged, 25 is unchanged, and everything from 0 to 25 is unchanged. But 26 goes into 26 one time with a remainder of 0. 27 goes into 26 one time with a remainder of 1, and so on, remainder of 2. And so if you always take, so I'm sorry, we're dividing 24 into 26, and our result is 0. We take the modulus of 24 into 26, and our result is 24. And then 26 into 26 is 1, 27 into 26 is 1 with a remainder of 1, 28 into 26 is 1 with a remainder of 2, and so on. And what we do is we use that property to do this wraparound part here. So I'm guessing that the number is 29. Somebody can correct me if they're not, if I'm a digit off. But basically, if you say index plus key, so we take X and we add 5 to that, that is 23. 23, 24, 25, 26, 27, 28. 28 should be C, because that's the number 2, 0, 1, 2, as far as the characters in our string. Those are the indexes. So that's how we get to a C in order to wrap around when we have something that, you know, where your letter plus the index isn't just a little further over in the string. We need to wrap around. And so the modulus, or remainder of a division operator, is what we use to do that. Does that make sense? Okay, good, good. Decryption basically just goes the other direction. We find the index, and then instead of adding the key to it, we subtract the key from it and then go and find the character. And so let's do encrypt and decrypt with terminal. And also take a look at this program and see if you feel like you recognize. I'll paste the link in first. Okay, so this is the link to the page where the example is. And then I'll also copy and paste the actual code. I'll come over and do this on one of our microbits. Oh, all points bulletin, use your caps lock key. Oh, I was supposed to enter the key. I typed my first letter. Okay, so we want to enter a key. So I'll just do 5 since we were doing 5, and then we'll enter the letter M. And the result is R. And then we'll try X. And sure enough, the result is C.
Sandy, we do the encrypting one terminal and the decrypting the other, correct?
Sorry, the computer audio is breaking up a little bit, so I'm
okay.
having trouble hearing.
Okay, just double checking because I'm taking notes and doing everything. So the encrypt code is gonna go in one of the terminals and the decrypt in the other, correct?
This
in
is
the other microbit.
Well, yes, eventually. Right now, we're just experimenting. This particular script is just experimenting with encrypting. Yes, but yes, in just a couple of minutes, we will encrypt, transmit over the radio, receive, and decrypt. All right. So
this one reminds me of Enigma.
Yes.
German, yeah.
Yes, as a matter of fact, see, I believe I did it in encryption. I thought I mentioned Enigma. Enigma, was that the German encryption that was really hard to decipher,
Yeah.
and we ended up figuring it out eventually?
We had to build a computer called Colossus, and it was the first big computer.
Yeah, I apologize. I don't remember where that is, or if that's in these tutorials. But yes, that is often cited when talking about basic ciphers.
we couldn't tell them right away, or we couldn't use the information right away.
Yep.
Because we were waiting to use it on a big scale. So
Yeah.
we had to let something happen so that they didn't think that we had the solution.
Yeah, and I'm sure for the leaders who knew that lives were being lost, that was a very difficult decision.
Yeah.
But yeah, that was a big war too.
Well, thanks.
All right, so let's see here. Now, applying the Caesar cipher to words is also kind of fun. And with this one, you can essentially try encrypting and decrypting. So I'll just demo this real quick and then paste in the link. Okay, so this script will allow you to encrypt by adding and then decrypt by subtracting. Or if you want to subtract and then add, that's fine too. And so the students are going to go through and do this. And so we'll enter the key. I'll just stick with 5. And then hello should be MJQQT. And then, so if we do a key of -5, JQQT. So there's the encryption with the positive value and the decryption with the negative value. And here is the link. And the text. And the code. There you go. So try that out, and then hit the thumbs up button when you've got it running, or give me a thumbs up. You guys are fast. I should have been hauling along. Looking good. Okay, getting some thumbs up in the chat too. Thank you. It does seem to be case insensitive. I'm seeing a comment in the chat. I thought I actually made a mistake when I accidentally typed in lowercase the first time. Let's take a look at the code. I might, oh, look at that. So letter in Word. Actually, this is something I'd better. So this is the for loop that crawls through the word, and it does it one letter at a time. But this for next loop might not look familiar to you because there isn't any index. I mean, some of you may have only done 4-letter in range, length of word. So word is whatever we type in, and it can be a string. The input function waits for us to hit return, and then we have a whole string of characters like hello or MJQQT. And 4-letter in Word goes through, and the first thing that it does is it takes the letter and it changes it to uppercase. That's why it's case insensitive, to address that comment. Then the other thing, and I'll just do this in a different with a different microbit here, is I meant to show you this. So what we're using here with 4-letter in Word was introduced a little while ago as auto iteration. And so as I mentioned earlier, some of you may only be familiar with 4 index, in range, start, and finish -1. So so if we have S equals a message, and then L equals the length of S, we're going to print the length. And then we're going to do the you know, the old school way of going through a string in this case. This also applies to lists and tuples and I think those are the two main ones. I don't know that you can do this on a dictionary, though I could be wrong about that. So here's a for loop that goes through one at a time using an index. But here is the auto iteration version where we just say for, and then this is going to go and grab the little pieces and they're going to end up in C, and then S again is the starting string. And so when I run this, I'm going to copy it. The code's a little different. So that the first one, since I do have the index, I'm displaying the index of each character. But if my code doesn't really care about the index and I just want to go through and display each character, look at each item in the list, you can use the auto iteration feature, which again is just instead of for n in range 0 to the length of the string, you can just say for some variable that stores characters, and then in S, which is the larger thing that we want to parse through.
Lana has a quick question. I may need to run soon to run too soon, but is the idea that we can encrypt before sending and then decrypt the received message?
The answer is yes, and in several different ways. And then after that, if time permits, we'll also talk a little bit about brute force attacks. And so, yeah, and we'll post the video of this about 3 to 4 hours after the session ends, so you can take a look at whatever part you missed later. Okay. So yeah, not to worry, you won't miss anything. Or rather you'll be able to catch up on anything that you didn't get to see. And the homework will be pretty minimal, and I'll send an email out about it. It's just mainly making sure that you can get into the Parallax Educators part of the learn.parallax.com site. All righty, so where were we? We were applying Caesar Cipher to words. And so let's see here. You can, of course, we talked about functions on Monday. So this is simply an example where we're putting the Caesar Cipher in a function so that your code can just say Caesar and then give it a key like 5 or whatever number you choose, and then the letters that you typed in. And so this makes it so that your main code down here is a lot more manageable. And of course, we can take this a lot further, make an object, put it in a module, all that kind of good stuff. And then this code becomes very small. We're going to talk about that there are some other ciphers. So the Ascii Shift basically generalizes this to ASCII characters. So I believe 0 to 128. And so, oh, actually, we're only, looks like, are we only going up? We're doing 32 to 94 as the printable. Oh, no, we're doing 34 to 126. Is that right? Looks like we're going 32 to 126 for ASCII characters. And those are basically the printable characters. And so this is another cipher that we'll actually use a lot with the robots. And then it also talks about, oh yeah, we're going to do sniffing attacks and then brute force attacks. And we'll probably finish off brute force on Friday at the beginning of the session. So there are substitution ciphers. Now, this first one is kind of a weak substitution cipher because basically our alphabet is the regular alphabet and then the cryptobit is just the reverse of the alphabet. However, you can also simply make a custom cryptobit where you might take the A and stick it here, and then the B and stick it there, and then the C, put it right there, and so on. And that is a significantly harder to brute force attack way of encryption, because there's so many different possibilities on what the actual encryption key is, because you have basically a really gigantic cryptobit here, and then you can essentially, every time you get a D, 0, 1, 2, 3, 0, 1, 2, 3, you can just use whatever character you put in there. So this is a much stronger form of encryption. Relatively speaking, it's actually still super weak compared to, I think it's called AES 256 and whatever else is commonly used today. So that's the encryption chapter. Now we're going to move into sniffing attacks, how to both how to do them, or how they are done rather, and then how to use encryption to fight against them. So
What slide are you on?
I am on slide number 51. And it looked like I maybe had the brute force and substituted, I saw sniffing force attacks and defenses. It's just sniffing. So, all right. So taking a look at sharing something personal. So if you're sharing that, if you're a student and you're feeling blue and you're going to share that to your friend who has a microbit, you wouldn't want somebody else necessarily to see that fact. And so your intended receiver, if you're not encrypting, you'll send the sad face, and your intended receiver will see it, but anybody else who's sniffing on your channel could also see it. So here is a script that will send radio images from one microbit to the other. No, wrong page. Okay, so first of all, let's do the unencrypted version. Okay, so there's going to be a transmitter that's going to send images, and then a receiver that will display the images. And so, so this one, the images will appear on your microbit. I'll go ahead and just copy in the link, and we'll have you make sure that your microbits are one microbit is sending and the other is receiving. So here is the link. Just find the transmitter and receiver scripts and paste them into your python.microbit.org tabs, and make sure that one is sending while the other is receiving. And incidentally, this is not going to be in the terminal. These are going to be on the microbits LED matrix display. Actually, you can look at the terminal, but it should be happening in the display. Am I wrong about that? I might be wrong about that. Let's see. Flash. Okay, I apologize. No, so the code example actually does both. So we see it with the print statement, and we see it with the display.show statement. So I'm So here is what you want to see. There's the sad, happy, sad, and pardon me, angry. So again, you can see it in both the sender and the receiver's serial terminals, and then also on the receiver microbits LED display. So now I know that the microbit with the blue trim is the receiver here. Now, if you had a third microbit, and again, in a classroom, if you have a third student that's on a pair of students channel, he or she will also be able to see that happy, sad, angry transmission. Oh, yeah, thank you, Sylvie. You can see some flashing when you load the code. If you're not sure which microbit is which, you can basically look at the back of the microbit, and as I load the receiver script, you might be able to actually see this. As I load the receiver script, if I flash it, there should be a little flicker of light here. You know, it actually happened so quickly, I didn't see it. Yeah, I couldn't see that. Let me see if I can see it with my eyes. Nope, that didn't display for me. With larger programs, it will. And when it's transmitting, the one that's transmitting, every time it sends a value, you'll see a blip of the yellow light. But when, let's see, the receiver, does that one happen to blip its red light? Yeah, I'm not seeing anything except for the LED display changing on the receiver.
Yeah, that's all I see in mine too, and the only one is showing the image, right?
And that is true. That is true. Yeah, because you have one receiver. So your transmitter, all you'll see is a little blip on its yellow serial activity light. And then the receiver, you'll see an update of the image.
So Sheila says, so the display is only the receive.
That's correct. Only the receiver microbit is going to update its LED matrix, and it'll also, of course, show what it's receiving in its serial terminal. So you'll see send, angry, happy, sad, and then the receive will correspond angry, happy, sad over and over again. And there are also apps where you can press the button to pick whether you're happy or sad and send that. Now let's look at encryption with terminals. So this is, I think, really interesting. So this one's using a key of 19, and the intended receiver is able to see the messages, but since we're using encryption, the sniffing receiver only sees a bunch of, you know what? I skipped something. I'm sorry. Let me backtrack here. Share something personal encrypted. So we shared something personal, that being, an emoji of our mood, student-wise. That's what this, the idea is for the student, is to say, hey, if you're sharing something personal, do you want everybody to know it, or do you only want the, one person to know it? And so, so here we'll go ahead and encrypt happy, sad, and angry. And so this is going to be one that has transmitting and receiving scripts that are encrypted. And what I would like you to do is only update the transmitter first. What that's going to do is it's going to cause an exception in your receiver. So that's kind of fun. I'll show you that real quick. So I'm going to update the transmitter with encrypted code. Okay, so I'll flash this. And it's going to start sending. Now, instead of angry, happy, sad, there are other characters. But look what happened in my receiver. Now my receiver threw an exception. And so it's currently going through and displaying what the exception is on its display. And it's also displaying what the exception is here, that it doesn't know how to display an emoji that says DSSB. So that caused it to throw an exception, and now it's not listening anymore. So in order to get things to work, what we can do is update the receiver script, and remind me to give you the web address so you can try this. So now I'm going to update the receiver script, and then I should start seeing the happy, sad, etc. again. Flash, and then open serial. Okay. So, and notice that it's showing the encrypted and the unencrypted version of the text. All right, so go ahead and try this out. Chat, paste, there you go. Give me a thumbs up once you've got that verified on your side.
Sylvie is saying they got errors.
Well, when you have one that's transmitting, the receiver should have an error because it won't be able to figure out, it's expecting happy, sad, or angry, but only when I had exception with only transmitter updated, correct. Yeah, so you do want to have errors when you've only updated the transmitter, because what your receiver is at that point is a sniffer on an open channel. And the cool thing is that your encryption not only became unreadable, but it also actually crashed the code on your sniffer's microbit. And so then if the sniffer updates their code to handle an exception about that message, then it can keep on sniffing and potentially try to, brute force decrypt these ciphertext messages. Okay, so Sylvie, that's a really good comment. I see you're saying that this lab has some potential for AP principles when taught in Python, and I agree completely. It's really good for not just program. I mean, even though the subject is cybersecurity, it's pretty cool, and it definitely hits a lot of programming checkboxes.
And Cynthia has the social side of the question. So how would the person who receives it know the key?
Well, that is by arrangement. And actually, okay, so I have, this was on my list of chapters to write. One of the challenges that I have not yet published is the challenge of how to safely get the key to the intended recipient when it's not convenient. And so that in and of itself can end up being a challenge. And it's actually quite the challenge for, it had been quite the challenge for banks and other institutions when serving to your web browsers, when you're trying to check your bank balance without having hackers get in there. All right. Now we'll go to, okay, so hackers being hackers, they will figure out a way around it. And so the next page after this is how the hacker might then use use exception handling to prevent their sniffing program from crashing. But they still have to figure out how to decrypt the data once they get to that point. Next up is the texting with terminals encrypted. So what I would like to do here is I'm going to paste you in the text to run in both terminals again, that same old one. I apologize for having done it so many times here, but we'll go back and run the original unencrypted one on one of our guys. Let's see here. Okay, so texting with terminals, encrypted versus unencrypted. So I need to go back a couple slides and grab the bidirectional texts script and give that to you to load into one terminal or into both terminals to begin with. Okay, so we want to make sure it's working unencrypted. So here is the unencrypted version of the chat. So let's all get that working. Yeah, since this is the first time I did it and I really did not know if we'd be able to have conversations with between our microbits while on Zoom, I was maybe a little bit over concerned about this application because it looks like 98% of you are okay. Okay, so we'll flash both of these in and just get our regular chat working. And then after that, okay, so I'm testing the chat now. I pasted it into you. Hello. Okay, so sent from that microbit to that microbit. Hi. Oops.
Here's a good question from Svetlana. What's the physical distance, the range of these two microbit modules? And does it, is it consistent from one model to another? I mean, if they're in the same classroom, will it be okay? Or do they have to be a few desks away?
It's in the same classroom. And I actually have some notes about that. Let's see, where are they? That's going to be in the radio basics. I think it's in the introduction.
And then there's outside line of sight. I'm assuming Cynthia's.
Yeah, Cynthia's got it. So 230 feet line of sight, no obstacles. So in other words, when you're outdoors, you're not across walls or anything, 230 feet is where you can get. Ah, Cindy, you're thinking about your robotics contest for now. Cindy, do you want to do a plug for that real quick? Sorry for putting you on the spot.
What kind of plug?
Well, your student groups have gone to and won these robotic sand dune navigation contests repeatedly. So would you like to just mention what you do with your group?
Well, I teach community college, but I have kids from 9th grade to, well, last year was 36th. and we go to the sand dunes and we have to build an autonomous robot and navigate autonomously through anything they throw in our way. So that's the sand, rocks, they dig pits, they build walls. And yes, we have taken first since 2009. So we're the college to beat in college in Colorado, and that's even beating Mines and Boulder, Mesa, any 4-year. This year we did mapping. So we built 5 little robots, and the robots communicated with the parallax towers with, I think we used up every ping in our inventory, as well as cannibalizing previous rovers. So I think we had over 20 something pings running, and they created their own autonomous map at the sand dunes. Without, it just would appear on our computer. So that was pretty cool.
That is amazing.
We do have a YouTube channel.
Go ahead and paste it in the chat to everybody.
Okay, I have to find it first.
Okay, but yeah, paste that in.
Browser window.
Yeah, and congratulations on that amazing winning streak.
Yeah.
Please pass it to your students.
No. But yeah, I'll paste that in the chat. This year we're starting over, so I have 2 9th graders up to, I think my oldest is 18. I don't think I have any college students this year. I mean, real college students.
Wow.
So let me just paste that in our chat here window.
And then
right running on a jetpack.
Okay, and then what I'm going to do is just take us through the conclusion of the messages. I didn't realize we were at the 2-hour mark, so if you could stay with me for just a couple more minutes, we'll wrap it up here. So now that we've done the basic bidirectional, what we'll do is we'll encrypt our transmitter, and then that way we can see what a sniffer who was looking at non-encrypted messages would see. Okay, so what you want to do is basically just close serial and then paste it into your transmitter, but leave your receiver alone. So flash, and then serial, and then we'll enter a key of 5, I guess. And then if I say hello, we got the MJQQT. And so I'll paste this into you. And I think it's actually works for both. Yeah, it works for both directions. So we'll be pasting this in to the other one in a minute. So just get 1 microbit going with the encryption first so that you can see what the sniffer would see. Sorry, I'm looking for the chat. And give me a thumbs up when you've got that going. And then once you've got that going and that you've verified that there is, ciphertext showing in the receiver, then go ahead and update the receiver for encrypted, give it the same key, and you'll then have a safer channel to communicate over. And likewise for your students when they do it. So paste, oopsie. I want to paste the script, copy. Flash. Five. And now we are encrypted. And if you have a 3rd microbit, it's kind of fun because you can use the older one, the older script on that one. So video wise, this is pretty telling. I'm going to line up all three of my microbits and run one without the encryption. And the other two with the encryption. So as you can see, I typed in, hello, can you see this? The receiver displayed, hello, can you see this? But the unencrypted receiver displayed something that's kind of difficult to decipher. And then, my other encrypted receiver, I'll respond, yes, I can see it. And we still get a bunch of crazy talk. And so this right here is a thing where I would want to have 3 students working together. One wearing the black hat, the sniffing hacker, and then the other 2 using the encryption.
So this only works with 3 microbits?
No, it works with 2. It's just not as striking. I mean, the idea is to have an entire in-class classroom involved with this, and so that there's a secure channel and there's a hacker. So yeah, there are some 3 microbit activities. This one I recommend doing 3, but I did it in a way so that you could see with your second microbit when the communication looked like this, and then you updated it to be encrypted, and then the communication looked like this. So that is but it's not as striking. I don't feel like it brings home the message, the point, the idea of the activity, as well as if you have one microbit that's performing the sniffing attack, and then suddenly its ability to do so is foiled by the cipher.
And so it wouldn't be 3 per student. It would be maybe 3 students with 1 each in the classroom playing different roles in the scenario.
That is exactly right. 3 students, each one playing their own role in the scenario, and each one with 1 microbit. Yeah.
So Andy, I have the code on both the sender and the receiver, but it's not decrypting. Why is that?
Generally, maybe you entered -5 instead of 5. I believe the key is automatic. Like if we look at this code, we'll see that the key is positive here when we're sending, and then the key is negative here when we're receiving. So when a message comes in, we use a negative key. When the message goes out, we use a positive key. So make sure to run both and enter the same key number. So it should be, if it's going to be 5, it should be 5 on both transceiver A and transceiver B.
I did that, so I don't know what's going on.
Let me see if all the text, let me see if I can paste the whole program, less the comments. Want to make sure that you have both running. There we go. No, did that not give you? I don't think that's right.
It's the same code for both, huh?
Yeah, it should be the same code for both. Let me give you the web page again, because it's a transceiver script, meaning that it goes both directions. So there is the link, and make sure to copy this script. There's only one script on the page. Make sure to copy the whole thing and then make sure to paste it into both of your editors. Control A, Control V. We'll select all and then paste. Control A, Control V. Flash, flash. Open serial, open serial. And then enter the same key for both. I'll do 7 this time, but I'm doing 7 in both of them. Have to hit enter in both terminals. And then when I'm ready to send, can I get some thumbs up? Have you guys been able to get that to work? Did you see the ciphertext and then the deciphered plain text? Good, lots of thumbs up. Okay, so I will send out your homework again. It's mainly going to be just to make sure you can sign into parallax.com to see the teacher resources. And an important thing, don't worry if you get stuck signing in, just let us know, hey, I'm stuck. It's not so much that I, will be having you go through the teacher resources. It's just that as I show the teacher resources, I want to do so with the confidence that you can get in there and download the teacher, the solution sets and so on, because you are able to sign in to learn.parallax.com as a teacher is all. So don't worry if we don't get you all sorted out before Friday, but do your best to either use your old learn.parallax.com login to log in, or you'll have received an email from us saying that a new account was created for you if it doesn't look like you had an account prior to this workshop. And we'll pick up with brute force attacks and defenses on Friday, and then look at the curriculum resources. And thanks for coming, everyone. And I really appreciate your great comments. Bye-bye. Oh, and by the way, anybody needs support? Stick around. If your computer was not cooperating, or if you couldn't get an application to go ahead and stick around. We'll help you out. Stephanie, would you like to stop recording?
All right, I'm stopping the recording now.
Thanks again, everyone.